Okay, we're going to continue talking about probability, but now we're going to talk about simulation. And a simulation is when we are going to imitate chance behavior. And so we can do this by flipping coins to represent the gender of a child that a person may have. So heads could be male, tails could be female, and I flip it and I can imitate the probability of getting a girl or the probability of getting a boy. And so just kind of that idea of it, because we typically have just the two genders, male, female, and flipping a coin has two outcomes, heads or tails, and so it allows us to imitate that chance behavior. And so we are starting to get into a lot more free response type questions, and so we have typically a 4-step process that allows us to write out thoroughly what's happening. And so it's just kind of a guide to you on the correct way of writing out a free response to cover all your bases. And so our 4-step process is the state, plan, do, and conclude. So the state for simulation is, what is our question of interest about the chance process? What are we trying to figure out? Because if you don't know what you're trying to figure out, then your whole process of going about the problem can be totally wrong. So being able to state exactly what you're trying to find gives you an idea mentally of what you're trying to figure out. It gives you a kind of where you're going to go, and then it also, when it comes down to the conclude part, you can go right there and it helps you write up your conclusion better. And because after you've gone through that whole process, sometimes your mind gets bogged down. You're like, what was I doing again? And going back to that state part gives you a way to write up, this is what I did, this is what I'm finding, this is my information. Now your plan is, how do you plan to use the chance device? So really thoroughly describing what you're going to do for the simulation to represent that chance. So going through and saying that since there are two genders, I'm going to use flipping a coin to represent the chance process of getting one of the genders. And I'm going to assign heads to be males and tails to be females. And then I'm going to flip a coin 7 times to figure out what's the probability of getting a girl all 7 times or something. And then I can repeat that over and over and over, so I can look at many, many simulations and kind of look at those probabilities and how that ends up laying out. And you have to make sure that you're really explaining everything so someone else who reads it understands it. So this is a really good time to, when you're writing this stuff out, say it out loud to yourself and listen to how it sounds. Does it make any sense? Could someone do exactly what you say just by reading that? Could they totally mimic your process? And then so then you're actually going to go ahead and do the repetition of the simulation. So you'll do many, many of those repetitions. And that's where you're going to show your results. You're going to do all that type of stuff. And then you're going to go ahead and, after you're done with your simulation, what are the results? What does it tell you? What did you learn from that? Okay, so we have a sample problem called the golden ticket. At a local high school, 95 students have permission to park on campus. Each month, the student council holds a golden ticket parking lottery at a school assembly. The 2 lucky winners are given reserved parking spaces next to the front entrance. Last month, the winning tickets were drawn by the student council member from the AP Stats class. When both tickets went to students from the same class, that same AP Stats class, some people thought the lottery had been rigged. There are 28 students in the AP Stats class, and all are eligible to park on campus. Design and carry out a simulation to decide whether it is plausible that the lottery was carried out fairly. So this is kind of leading us up to, how would you do your state, your plan? I typed out a bunch of stuff so you wouldn't have to write it all on your own, but this is how you would write out your problem. So we'll start with our state. What is the probability that a fair lottery would result in 2 students from AP Stats? That's what we really want to know. What's the probability we'll get 2 students from AP Stats? So here's our plan. We can't use a flip of a coin because we don't have only 2 possibilities. We have 95 students that we're picking from, and 28 of them are from AP Stats. So we're going to use a random digit table. So table D is that random digit table in our textbook. What we're going to do is we're going to label our 28 AP Stats students 0, 1 to 28. So 1 to 28 is going to represent our AP Stats students. Now the rest of the numbers, 29 through 95, are going to be students who are eligible to park on campus, but are not in that stats class. How do I know up to 95? Well, it says up here, 95 students have permission to park on campus. We are going to skip, though, the numbers 0, 0, and 96 and 99. And so we're going through and we're describing how we're going to do this thoroughly so someone else could do it and get the exact same results. We're going to move across the row and we're going to look at pairs of digits. Why pairs? Because all of our numbers are 2-digit numbers. And we're going to look at that until we come across 2 different labels from 0, 1 to 95. And the 2 students will be the winners of the prime parking spots. And we're going to record if they were from the AP Stats class. And then we're going to do this over and over. So that's just one simulation. And then we're going to do it over and over and over. Okay. So we're starting at line 139. So this is what the random digit table would look like. These are the line numbers. They're not our actual numbers that we're going to use. And so we're going to go ahead and look at this. So we have 55 and 58. So 2 different numbers. Were they both in stats class? No. So this is a no, and this is a no. Because for stats class, they need to be 0, 1 to 28. Okay, so now I'm going to go to 89 and 94. So are they both in stats? No. And then we're going to look at 0, 4. I'm trying to get a different color for a different simulation. So 0, 4 and 70. So this is a yes, and this is a no. Okay, so then we have 70 and 84. And this is a no and a no. And then we have 10. And then 98 is not one of our numbers. Remember, we're skipping 0, 0, and 96 through 99. So we've got 10 and 43. And 10 is a yes, and 43 is a no. And so then I'm going to go to the next one. 56. Hold on, I have a hard time. So 56 and 35. So this is a no and a no. And then we have 69 and 34. A no and a no. And then 48 and 39. A no and a no. And then 45 and 17. A no and a yes. And then a 19 and a 12. That's a yes and a yes. So if we were to stop right now, then we could say that in our simulation we did a simulation, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So in our simulation we did 10 times. How many times did we get both of them? 1 out of 10 times. Which is really a 10% chance of that happening, which is not all that low. It's low, but it's not all that low, and it's not impossible. It's not like a 0.1% chance of happening. No, and it didn't actually take us very long before we got the double yes. So we could keep going. And again, the more simulations you do, the more accurate your information is. But for time purposes, you don't want to watch me go through and do 100 simulations right here. But you kind of get the idea. The more simulations you do, the more accurate that probability is going to be. Because again, the more simulations, the closer it comes to the true probability. And so we may find that it's actually higher than that. We may find that it's actually lower than that. But the fact that it didn't take me very long before I got to one that was actually there shows me that it's not going to be a really, really low probability. So in our simulation, both winners came from the AP class 1 out of 10 times. So approximately 10% of the time, both winners will come from the AP Stats class by chance. It is a fair lottery. Now, again, if you were to continue on and you found that that percentage started dropping, and then all of a sudden you're down to like a 1% chance, then you may go ahead and say it's not a fair lottery. But again, you'd have to go through all of that work. And then the more work you go through, the more that accurate your results are going to be. And so that's why we start looking at, when we start picking samples, we want lots of people. When we start doing simulations, we want lots of these, because the more accurate our data is going to be. Okay, so at the following month's lottery, the two chosen were again from AP Stats class. This raised suspicions again, like no way. There's no way. How would you modify the simulation in the previous example to estimate the probability of this happening again just by chance? Use line 105 to carry out just one simulation. And so this looks like a very typical AP Stats type of question. Like, we want you to figure out, how would you do this? Describe it, and then actually go through one simulation. So now we're looking at not 2 people in a row being picked from AP Stats, but all of a sudden 4 people. So now we're not looking at 2 groups of numbers, we're looking at 4 groups of numbers. So we could describe this by saying we would look at 4 sets of unique 2-digit numbers. And why do I use the word unique? Because at least for the 2 sets of 2-digit numbers, we're not picking the same person for that parking spot. So we're wanting to make sure that we're not getting those repeaters in there. Though technically, we could have a repeater. A person could be picked one month and again the next month. And so we may want to be a little bit more clear of that. 4 sets of unique 2-digit numbers. And then clarify what we mean by unique. Unique where the first 2 are not the same. And the second 2 are not the same. The more accurate you can be about the way you write this out can reduce confusion and actually increase your point score. But if you describe it incorrectly, if you're not very clear about that, it will actually hurt you. So you have to really think about how you're going to write that out. And calculate the probability that all 4 sets are in the range. Actually, not the range. Are in the AP Stats class. Reiterating to myself, that's 01 to 28. So let's look at our first sample. So my first number is 95, and then 59, and then 29, and then 40. So it looks like we only have one of those from the AP Stats class. And so then you can actually write that out. We have 95, 59, 29, 40, and then you can write, are they in stats? No, no. Oh, this is a no. Sorry. No and no. Actually, accidentally made a mistake there. I apologize. And so there's our one simulation. And if they wanted us to do 3, we could do 3. And we could keep going and kind of look at that. But they just want to know, do you understand how that would look? How would you go about doing that?